Inside a dwelling, you can get 500, 600, 800, 1,000, even up to 1,200 degrees Celsius in terms of heat. Outside the dwelling, it'll depend on how far you're at and where you're standing. But as you get closer, you'll be exposed to that temperature and also the heat flux, the radiation from it. And if you get too close, you can get first, second, third degree burns very quickly from the fires as they occur.
Density of an informal settlement, which is the main cause of massive fire outbreaks and disaster. The density of former townships are also increasing in such a way that people are very close to, structures are close to one another, and if there's fire in one, it automatically spreads to many households and affects so many households.
I think one of the issues of fire risk in informal settlements is this densification, because what we find now is that there are often passages that lead to dead ends. So there could be 4 or 5 or 6 shacks all clustered together because they're a clan group or a family organized group. And they're configured in a certain way to help each other and for security reasons. And often that path leads to a dead end and there is no other way out. And that for me is what is really terrifying.
You always need something to start the fire. It might be someone falling asleep with a cigarette, it could be an electrical fault, it could be knocking over the paraffin stove. And depending on what it is, it might be a few seconds to many, many minutes before the fire goes from a little spark and then it slowly starts burning over the surface of what's near it and then starts spreading throughout the dwelling. So someone falls asleep on the couch and their cigarette falls onto the couch and ignites the fire. Very soon thereafter, smoke starts rising up and filling the room. And what happens at this stage is this smoke, if it descends low enough, may cause the person to asphyxiate. But now if flames start and it starts releasing hot gases, those hot gases build up at the roof. And what happens now is this hot gas, when it gets to about 500 to 600 degrees Celsius, is radiating heat down onto the floor. And you get what's called flashover, where this radiation is strong enough to suddenly cause everything in the room to ignite. And then you go from the couch burning to everything in the room now on fire. Everywhere that is exposed is now burning. As fast as air can enter the dwelling, it'll burn. And now what even happens is we start running out of oxygen and then the flames start coming out as it looks for oxygen. And you have big flames emerging from windows and doors and any other opening, and also air being sucked in. At this stage, the fire can now rapidly spread to the next dwelling. The flames may impinge, it may hit the next dwelling and then come into little holes. It may ignite any sort of combustible material on the next dwelling. And once the next dwelling is ignited, it'll slip in and maybe start burning the cardboard on someone's wall or the newspaper, or maybe the door's been left open or the window cracks and breaks out. And then it quickly then spreads through into the next dwelling, around it, and soon we have the next dwelling on fire as well, and the story continues as more and more dwellings catch fire. In terms of fire behavior, a useful thing to understand is the fire triangle, also called the fire tetrahedron. We need all these 3 components. You need oxygen, which comes from our air, you need fuel, and you need heat. If you remove any of those 3, you stop the fire. If you remove oxygen by putting a thick blanket on your fire, you smother it, it goes out. If you remove the heat by putting water on it, you cool it down, fire will go out. Or if you remove the fuel by just taking the fuel away or knocking down homes so the fire can't get to the fuel, it'll go out. And in the middle, you've got a chemical reaction. We don't normally do this, but you can also stop the chemical reaction from occurring to stop the fire. We have 3 main types of ignition for a home. Firstly, what you have is flame impingement, where the flames from one dwelling come in and then can ignite something on the other dwelling. Then we have radiation, which is electromagnetic waves that radiate over a distance and can actually ignite something at a distance. And then lastly, we have flaming brands, where little pieces of burning material get transported by the wind, and they can land a distance away, be it a few meters and sometimes many, many meters away, and cause spot fires. And any of these can cause ignition. But what's also important is that other items can ignite around a home, whether it be rubbish or materials, and then cause a fire. And then also we may have ignition through a door, through a window, through openings, etc. And then those are weak points where the homes are most susceptible. Understanding fire behavior is key when it comes to looking at what will work. I may have a great product which works absolutely beautifully on a formal building, a paint, a board, a throwing fire product, whatever it is. If we don't understand though what a fire looks like in formal settlement, we might provide a product that doesn't work. And we've seen it many times. Many millions of rands have been spent in South Africa and around the world on products that are not suitable because we don't understand fire spread between dwellings. We may not understand suppression and how to put a fire out, and we may not understand what ignites, how to detect a fire. What does detection mean, and at what point will my device go out? So understanding fire behavior is key when it comes to evaluating interventions. Before you try any intervention, has it been tested? And has it not just been tested with the community, has it been tested in a technical environment in terms of fire behavior? So we need ongoing research, ongoing development of any product that we are rolling out in our communities to make sure that it can work and it can do what we say it does, and it can do what we say it does when it's needed. Is it a small fire, big fire? And can the community use it? Can they find it when the fire breaks out? And all these factors, are they considered?